All right, welcome everybody. Thank you for tuning in to the Chapter 2 introduction video. Chapter 2 is all about polynomials. While we're going to spend most of our time talking about polynomials of degree 3 and 4 and 5, we have to make sure that we are comfortable with degree 2, which is all kinds of quadratics in all of the different forms. In case you don't remember all the different forms, I sent you this in Teams, but I have also made a graphic organizer of all three different forms. So let me go ahead and pull that up for you. The three different forms that I expect you to know are vertex form, standard form, and factored form, which is sometimes called intercept form. If you take a look at each of these boxes, it shows you the equation. It shows you how to find the axis of symmetry, the vertex, the y-intercept, and the x-intercepts. So please print this out or refer to it if you ever forget how to find each of these different characteristics. It also gives you some reminders at the bottom. How do you determine if the parabola is going to open up or down? How do you determine whether you're going to have a min or a max? How do you decide if the parabola is going to be the normal width, narrower, or wider? How do you find the domain and range in interval notation? And then how do you find the increasing and decreasing? And remember, increasing and decreasing, you're going to use parentheses only. So back to our video here. Let's go ahead and start by just making sure we understand what it means to be a polynomial and what it means to be a polynomial in standard form. So standard form means anything that could be multiplied is, and you're going to have to be able to find both the degree and the number of terms. So I would expect you to know degrees from 0 to 5. If you're going to name your polynomial using the degree 0 is constant, linear, quadratic, cubic, quartic, and quintic. Then you also have to be able to name your polynomial with the number of terms. So 1 is a monomial, 2 is a binomial, 3 is a trinomial, and then anything 4 or more is just a polynomial. For this center column here, you would have to give it both names. So 6 would be a constant monomial. 2x cubed minus 5x squared minus 2x would be a cubic trinomial. So again, you have to be able to name a polynomial based on its degree and its number of terms. We're going to go ahead and start with, again, just a brief look here at each of the three different forms, standard, vertex, and factored. Notice that for each of these forms, really the only thing that's the same is the A. So in each case, the A tells you whether the graph will face up or down, whether it's positive or negative, and it will tell you whether the graph is wider or narrower than usual. In terms of a polynomial in standard form, here are the things that I expect you to be able to do without a graphing calculator. On this next test in Chapter 2, part of it is going to be with a graphing calculator and part of it is going to be without. So in standard form, and again, here is a snapshot of the graphic organizer. So if you were to forget how to find each of these components, simply follow along here and go ahead and calculate each one. So in order to find the vertex, you're going to use the formula negative b over 2a. In order to know who a, b, and c are, the a is the value that comes first. That's a negative 1. The b is 6, and the c is 7. Sometimes it's helpful to go ahead and write those down. In order to calculate a vertex, you're going to go ahead and do x equals negative b over 2a, which in this case would be negative 6 over 2 times negative 1. Make sure that you calculate the bottom, then go ahead and divide, and you're going to get a value of 3. That 3 is only the x value of the vertex. In order to find the y value of the vertex, you would very carefully have to plug a 3 in for all the x's, follow order of operations, and find the corresponding y value. So 3, 16 is the vertex of this quadratic. In order to find the y-intercept is always very, very easy to find from standard form. It is always the c value, which means the value by itself in the back. So no work required, 0, 7. In order to find the x-intercepts, you're going to go ahead and set y equal to 0 and then solve it using a variety of strategies. In this case, if I go ahead and set this equal to 0, the fact that there is a negative out front, I don't really like that. That tends to make things harder in terms of factoring. So I can go ahead and divide everything by a negative 1. When I do that, factors of negative 7 that add up to be negative 6 are minus 7 and plus 1. What you have done now is you have factored. So you're going to go ahead and you are going to set each of these parentheses equal to 0. You're going to solve each one. That is going to give you x-intercepts of 7, 0, and negative 1, 0. Once you have found all those values, you're going to go ahead and make just a sketch. A sketch means you don't need to actually count in certain values. You just need to give me a broad picture here. So 3, 16, so up at 3, 16, 0, 7 would be around here. Remember that the axis of symmetry would go through the vertex, cut the parabola in half, and there would be a reflection point on the other side, the same number of units away. Then you have an x-intercept at negative 1 and at 7. Go ahead and connect the dots. The fact that the a in this problem was negative 1 means your parabola should face down and it should be the normal width. At this time, you can feel free to hop over to the Delta Math assignment, as question 1 is exactly like this about standard form. If you want to save that till later, let's go ahead and talk about vertex form. So in vertex form, notice that it looks completely different. There are no A, B's, and C's. Instead, there are H's and K's. So again, to find these characteristics, please use this information. In order to find the vertex from vertex form, it's going to be the ordered pair H, K. You're going to always do the opposite H and the same K. So in this problem here, you're going to look inside, x minus 5, do the opposite. Look outside, minus 6, and keep the same sign. In order to find the y-intercept, you're going to put a 0 in for the x and then calculate. If you put a 0 in for the x, you're going to get 3 times 0 minus 5 squared minus 6. 0 minus 5 is negative 5, squared is 25, times 3 is 75. 75 minus 6 is going to give you an answer of 0, 69. To find the x-intercepts, you're of course going to put a 0 in for the y, or in this case, the f of x, and then you're going to go ahead and solve. This is obviously not factorable, so you're going to add the 6. You're going to divide by 3. You're going to get rid of the squared. How do you do that? Take the square root. When you take a square root, don't forget the plus or minus. The square root of 2 cannot be simplified. In your final answer, move the 5 over, put the plus or minus in the middle, and then the square root of 2. Those are your x-intercepts. And again, it would be x plus radical 2, 0, and then x minus radical 2, 0. The fact that you have a radical in your answer, it's still graphable. It's just a decimal. So from here, if I was going to go ahead and sketch this graph, I would start with 5, negative 6. Then the y-intercept is way up here at 0, 69. And then I know that if I go 5 units in the other direction, I'm going to get a partner point. Using my calculator, if I do 5 plus the square root of 2, I'm going to get 6.41. And if I do 5 minus the square root of 2, I'm going to get 3.59. So again, even though those are decimals, you can still graph them. So 3.59 and 6.41. Go ahead and connect them. Obviously, this is just a sketch, so let me go ahead and make that just a little bit nicer for you. Obviously, my graph is not going to be perfect because I estimated, but it's perfectly good enough to get the job done. From here, again, if you want to jump over to the Delta Math to do the second question, you can feel free. Otherwise, let's go ahead and take a look at factored form. So in factored form, there are no A, B's, and C's. There are no H's and K's. Instead, there are P's and Q's. So when it comes to something in factored form, you actually have to start by finding the x-intercepts. So generally speaking, the x-intercepts come from setting each of these parentheses equal to 0. If you're lucky enough to have a positive x, you can just do the reverse sign. So x minus 10 is going to give you positive 10, and x plus 4 is going to give you negative 4. The reason why you have to find those x-intercepts first is you now need to use P and Q in order to find the vertex. So you're going to do P plus Q over 2. So you're going to go ahead and do 10 plus negative 4 divided by 2. That is going to give you a 6 over 2, which is going to give you a 3, something. Again, in order to find that something, you're going to go ahead and take that 3 and plug it into each of these x's. If you do that, you're going to go ahead and get 1/2. 3 minus 10 is -7. Then you are going to do 3 plus 4 is +7. So you're going to get an answer of -49/2. And yeah, you can go ahead and make that a decimal if you want to. When you find a y-intercept, you always put a 0 in for the x's. So if you put a 0 in for the x's, you're going to get 1/2 times 0 minus 10 times 0 plus 4. Half of -40 is -20. Again, once you're ready to go ahead, to do the sketch, 0, -20. 3, -49/2. So -49/2 is -24.5. So that's going to be down here below it. Then if that was at 1, 2, 3, at 4, 5, 6, that's going to be your y-intercept reflection point. Then you're going to need a point over here at 10, a point over here at -5, and then again, you're going to go ahead and sketch those. I think that might be a little bit too far off there. Again, I'm kind of going quickly, not really counting precisely. Hopefully your pictures will be a little bit better. And again, on a test, I give you a coordinate plane, but I'm just trying to show you the mechanics. Okay, so then from here, what if you want to go back and forth between the two different forms? So what I have for you here is 2 examples of quadratics, both in standard form. I want to rewrite those in vertex form. So vertex form is y equals a times x minus h squared plus k. And whether you use y or f of x, it really doesn't matter. In order to take something from standard form and put it into vertex form, you are going to do the following. Step 1, you are going to find the vertex. Remember, if you're finding the vertex in standard form, it's -b over 2a. So if you do -b over 2a, you're going to get -4 over 2 times 2. That is going to give you a value of -4 over 4, which is going to give you a value of -1. You're going to take that -1, you're going to plug it back in for each of these x's. Very carefully calculate the corresponding y value, which in this case is -3. Once you have determined what the vertex is, you're going to go ahead and take a look at this fresh copy of vertex form, and you're going to go ahead and take whatever the a value originally was, and you're going to plug that in for a. So y equals, the a is 2. You're going to have a quantity squared. It always has to be x minus the value. If you're doing minus a negative, it becomes a plus. Remember, the k on the outside always stays the same. So here, your answer to this problem in vertex form is 2 times x plus 1 squared minus 3. Take a look at the second one. We want to go ahead and rewrite that into vertex form. So again, in order to do that, you have to start by finding the vertex. So I'm going to take this problem. This is actually the problem from earlier. In order to do the vertex, you're going to be -b over 2a. This is the same problem that it was earlier, so that's 3, 16. You're going to go ahead and start with a fresh copy of vertex form. And again, whether you use f of x or y, it doesn't matter. Whatever the a value of the original problem was, you're going to go ahead and snag it. So a is equal to -1. Then you have a quantity squared. It's always going to be x minus h, so x minus 3 squared plus 16. So going from standard form to vertex form, find the vertex, keep the a the same. Then lastly, what if you want to go from vertex form into standard form? Just so you know, this is a similar procedure as if you were going from factored form into standard form. You basically just have to do the algebra. So you're going to start by rewriting this as 3 times x minus 5 times x minus 5. That's what it means to b squared. It means there's 2 copies. I'm going to strongly suggest that you do this FOIL. So 3 times x squared minus 10x plus 25. Then you're going to distribute the 3, x squared minus 30x plus 75. Don't forget about the minus 6. In your final answer, go ahead and put the largest degree first, the linear in the middle, and then 75 minus 6 is 69. And again, this was a problem from earlier in the lesson where we calculated the y-intercept of being 0.69, which we can now clearly see from our standard form. So that is a little reminder of all three forms, how to find the important characteristics and how to go back and forth. You're now asked to go and do a Delta Math assignment. The Delta Math assignment should be short and it pretty much follows the order of this video. You will have a chance to ask questions in class, but we're going to spend the majority of 2.1 talking about quadratic applications as opposed to this basic stuff. So thanks very much for tuning in, guys. Don't forget to do your Delta Math, and we will catch you next time.